So we are live. Hey everyone, welcome to Practically We Bring Learning Alive. So as you know, we are going with this series 5 most important questions. So today we will be solving 5 most important questions from the chapter Surface Areas and Volumes. Right? So before going to solve, let us just check what topics are there, okay? So surface area and volume of cube and cuboid, cylinder and cone, sphere and hemisphere, combination of solids, and also converting one solid to another, right? These are the topics. So I have picked up the questions which almost includes all of the topics so that it will be a revision kind of for you. So let's start with the first one. A sphere of maximum volume is cut out from a solid hemisphere of radius r. What is the ratio of the volume of hemisphere to that of the cutout sphere? Okay, so first let us visualize this. Let us draw a diagram. Okay, there is the hemisphere of radius r, right? From that, a sphere of maximum volume is cut out from a hemisphere. So let us see how the sphere is placed so that it has maximum volume. So it is placed in such a way that right. So now this radius will be how much? R by 2, correct? Okay, so just let me redraw it neatly so that you will understand, okay? Yeah. So now the radius of the sphere is how much? R by 2. Now what do we have to find? Ratio of volume of the hemisphere to volume of cutout sphere. Okay, now we know the radius of hemisphere. We also know the radius of sphere. Isn't it easy to find the ratio of both the volumes? Of course it is. So, volume of hemisphere by volume of sphere. What is the volume of hemisphere? 2 by 3 pi r cube. So, this will be 2 by 3 pi r cube. Right? Next, volume of sphere. What is the volume of sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. But what is the radius of the sphere here? R by 2. So, this will be R by 2 whole cube. Right? So, pi gets cancelled, 3 gets cancelled, 2 times 1, 2 times 2. Okay? Now, this will be R cube by 2r cube by 8. So, r cube, 8 by 2, that is nothing but 4. So, 4:1 is the ratio. Right? This is one of the easiest problems yet most important one. Next. A metallic cylinder has radius 3 centimeters and height 5 centimeters. To reduce its weight, a conical hole is drilled in the cylinder. The conical hole has a radius 3 by 2 centimeter. So the radius of the conical hole is how much? 3 by 2 centimeter. And its depth is 8 by 9 centimeter. So when it says depth, can we consider it to be the height of the conical drill? Yes, of course. Calculate the ratio of volume of the metal left in the cylinder to the volume of the metal taken out. Okay, so first let us draw it. There is a cylinder, correct? So what is the radius of the cylinder? 3. Height is 5. So this is 5 centimeters and this is 3 centimeters. Now a conical hole is drilled. So let us just use another color. So here a conical hole is drilled. What is this radius? This radius is 3 by 2. So this is 3 by 2. And this depth or the height of the cone here is nothing but 8 by 9 centimeters. Right. Now what do we have to find? We have to find the ratio of volume of the metal left in the cylinder. So in the cylinder, when the cone is taken out, what will be the leftover volume? Volume of cylinder minus volume of cone, correct? So volume of cylinder minus volume of cone by to the ratio of volume of metal taken out in the conical shape. So what is it? It is nothing but volume of cone. So volume of cone. This is what we have to do. Now, whenever you are doing a ratio problem or whenever you find that there are some things we can take out common, please don't solve them separately and take the ratio, okay? Just write the ratio like this and solve using the same method, okay? So, this will be how much? What is the volume of cylinder? Pi r square h. Pi r square h minus what is the volume of cone? 1 by 3 pi r1 square h1. Right? Because the radius and height of cylinder and cone are different. So, let us take R1 and H1 to be the radius and height of the cone. Okay, by 1 by 3 pi R1 square H1. Now, we know the radius and height of all the things which we require, that is cone and cylinder. So, we can just substitute the values and get the answer. Okay. So, right. We can take pi common. So, R square. 3 square into 5, right? 3 and 5 are radius and height of cylinder. Next, 1 by pi we have taken common, so 1 by 3 r1 square. What is r1 square? 3 by 2 whole square. What is h1? 8 by 9. By again 1 by 3 pi 3 by 2 whole square into 8 by 9. Sorry, yeah. So, we can solve this, right? Pi gets cancelled. Then, this is nothing but 9 5s are 45. 45 minus 1 by 3 into 9 by 4 into 8 by 9. By 1 by 3 into 9 by 4 into 8 by 9. 9, 9, 9, 9. 4 times 2. 4 times 2. So, this 45 minus 2 by 3 by 2 by 3. 45 minus 2 by 3 by 2 by 3. So, this implies what is 45 times 3? 45 times 2 is 90. 90 plus 45 is 135. 135 minus 2 is 133. 133 by 3 by 2 by 3. This is nothing but 133 is to 2. So, this is the ratio. Got it? Next one. A hemispherical depression is cut out from one face of a cubical block of side 7 centimeters. So there is a cube and hemispherical depression is done. That is, the hemisphere block is removed. Okay. Such that the diameter of the hemisphere is equal to the edge of the cube. So diameter of the hemisphere is now how much? 7 centimeters, right? Now, find the surface area of remaining solid. So, for this, let us visualize, okay? So, there is a cube. Right? And what is done? A hemispherical depression is made. So, right? This is a hemispherical depression and this is 7 centimeters. This is also 7 centimeters. Now, what do we have to find? We have to find surface area of remaining solid. How do we do that? First, visualize, okay? There is a cube, there is a hemispherical depression made. So, if I want to find the surface area of the remaining solid, what does it mean? Surface area of a remaining solid equals to total surface area of cube minus the sphere, not sphere, I'm sorry, the circle, that is the bottom one or the top one in this case, that is this part. Because this part won't be seen, right, when you are calculating the total surface area of the remaining solid. So, minus pi r square plus the depression of the CSA of hemisphere, that is plus 2 pi r square. Right? Easy. Let us do it. What is TSA of cube? 6 into a square, where a is the side, minus pi r square plus 2 pi r square plus pi r square. Okay. Now, if this diameter is 7, what will be the radius? 7 by 2. So, radius is equals to 7 by 2. Right? I'm sorry. Yeah. So, let us substitute 6 into 7 square plus 22 by 7 into 7 by 2 into 7 by 2. So, this will be 2 times 11, 7, 7. So we 2 into 3.5. So 49 into 6, 6 into 49 plus 11 into 3.5. So this is 6 nines are 54, 6 fours are 24, plus 5 29, 294, plus 11 into 3.5 is 38.5, correct? This is one of the easiest way. You just have to learn the trick of multiplication of 11, okay? So this will be how much? 0.5, 8 plus 4. Okay, we'll just do it. 12, 13, 332.5. So 332.5. What is the units you have to check? Where are the units given? Centimeters. So square centimeter. Okay. Gaming Fire Army, this is for class 10, but I am sure for 9th and 10th surface areas are similar, except for the combination and all. So yeah. So Gaming Fire Army, which class are you? Are you of 9th or 10th? Okay, do comment, okay? I'll see. Next, the internal and external radii of a spherical shell. Okay. Now, whenever internal and external radii are given, we have to again make sure the volume, how to find the volume, right? Let us see. So, the internal and external radii of a spherical shell are 3 centimeters and 5 centimeters respectively. So, let the internal radius be R1, that is 3 centimeters. External radius be R2, that is 5 centimeters. Right? Now, it is melted. Okay, that spherical shell is melted. Then it is recast into a solid cylinder of diameter 14 centimeters. Find the height of the cylinder. Okay, whenever one solid is melted to the another solid, these both volumes remain equal. Correct? So, from this question, what can we depict? We can write that volume of, what is this? Spherical shell is equals to volume of cylinder. Now we have to just use the formulae and get the answer, right? So what is the volume of spherical shell, or what is the volume of sphere? 4 by 3 pi r cube. But if you see, the internal and external radii are given 3 and 5 centimeters. So to find the volume of the shell, so let us assume like this is the shell. This is recast into a cylinder, right? So this is 3 centimeters, this is 5 centimeters. Now how do we find the volume? 4 by 3 pi r2 cube minus r1 cube equals to, what is the volume of cylinder? Pi r square h. So we know the height. No, sorry, we know the diameter, we have to find the height. So pi. Now just substitute the values. 4 by 3 of 5 cube minus 3 cube is equals to, what is r? If diameter is 14, then what will be the radius? 7. So 7 into 7 into h. Come on, let's solve this. 4 by 3 into, what is 5 cube? 125. And what is 3 cube? 27. Is equals to how much? Sorry. Is equals to 49h. So yeah, from here we can do it, right? It's easy. So 4 by 3 into 125 minus 27. So this will be 15. This is 1. This is 9. This is 8. Okay. Right? Next. Okay, units. I'm so sorry. Okay. Water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeters into a cuboidal pond which is 50 meters long and 44 meters wide. In what time will the level of water in the pond rise by 21 centimeters? Okay. So let us see this. So there is a cylindrical pipe. The diameter of it is 14 centimeters, right? And there is the cuboidal pond. The length is 50. 21 is height and 44 is width, right? Now what do we have to do? In what time will the level of water in the pond rise by 21 centimeters? That is why here the height is considered to be 21 centimeters. And there is one point we have to remember while doing this question is the units are different for different parameters. So here the height is given in centimeters, then length and width are given in meters. Next, water is flowing in kilometer per hour. There are like various units, correct? So what is the first step we have to do? We have to convert into one unit. So let us convert everything into meters. Okay. Now, water is flowing at the rate of 15 kilometer per hour. So in 1 hour, it is traveling 15 kilometer. Right, that is nothing but length, or you can say height of the cylindrical pipe, correct? So height is equals to 15 kilometer. That is nothing but 15,000 meters, right? Next, diameter is 14 centimeters. So radius is equals to 7 centimeters, which is nothing but 0.07 meters. So I am converting everything into meters, okay? Now, next, this is for cylindrical pipe. So, we will find volume of pipe. 1 by 3. No. What am I doing? No one is literally answering me anything. It's like just I am telling it to myself. So, yeah, please edit. If someone is watching, share it with your friends. This is most important. It will be useful for you. Okay, so this is pi r square h. Substitute 22 by 7 into, what is r? 0.07. So 7 by 100 into, 7 by 100 into, what is height? 15,000 meters. So 15,000. Okay, so come on, let's do the cancellation required. 0, 0, 0, 0, 0. So 22 into 7 into 22 into 7 by 10 into, what is this? 15. Correct? So this is what, let's keep it, because there will be some calculation done and it doesn't seem, it seems time consuming also. So just let us leave it like that, and while finding the time, let us see the cancellation. Okay? Right. So, did we take this correct? 22 into 7 by 10 into 15. Yes. Now, it is time to find the volume of cuboidal tank. Volume of cuboidal tank is equals to length into breadth into height. Correct. What is the length given? 50 meters. What is the breadth given? 44 meters. But height is given in centimeters. So, first we have to convert the height into meters. So, height is equals to 21 centimeters. This is nothing but 21 by 100 meters. Right? So, let us keep 21 by 100, or you can write 0.21. Doesn't make any difference. Okay? Now, 50 into 44 into 21 by 100. So, 50 times 2, 2 times 22. So, this is 22 into 21. Right? Now the time taken. So, time taken. What is the time taken? Volume of cuboidal tank by volume of cylindrical pipe. We know the volume of cuboid, we know volume of cylinder, that is pipe. Substitute, get the answer. So, this is 22 into 21 by, what is the volume of cylinder? 22 into 7 by 10 into 15. Right? So, this is the reason I asked not to solve it completely and make it as it is. So, here we see that 22 is getting cancelled. Correct? Then 5 times 2, 5 times 3, 7 times 1, 7 times 3, 3, 3. So, 1 by 2, that is 2 hours. So what is the time taken? 2 hours. Okay, again, this is also one of the most repeating problems from like for past 5 to 6 years. Okay, so just go through these type, because it is not always given from a cylindrical pipe to cuboidal tank, correct? Sometimes it is given from a cylindrical pipe to cylindrical tank, or cubical tank, right? So it depends on what solid we can take, and make sure you learn all the formulae prior to your exam. Okay. All right. So let's see. I guess this is the last question. Yes, this is the last question. So I hope your preparation is going well, and please go through our one shot which was made in English and Hindi, and also we are doing this 5 most important questions for you so that it would be helpful. Okay, and at 1 p.m. you have physics class. Do join. Thank you everyone. Bye bye.